Warning, the things you're about to see were taught by the legendary Miss Chapman. Prepare yourself in molecular shapes.
Don't be like Miss Bunsen and me and get hurt. Follow these safety tips. Don't grip too hard. 2, do not get ink on yourself. And last but not least, make sure your bonds are straight. We don't want bonds to break.
To determine the shape of bonds, you first find the number of electrons needed.
To do this, we're going to use this H2S equation, and hydrogen has the availability of having 2 valence electrons. So there's 2 in the equation, so you take 2 times 2 and it equals 4. There's 1 sulfur in this equation, and it has the availability of having 8 valence electrons. So 1 times 8 equals 8. And then you do 4 plus 8, and you'll have 12 electrons needed.
The second step, you find the number of electrons available.
Once again, you have 2 hydrogens in the equation. It has 1 valence electron. 2 times 1 is 2. And you have 1 sulfur in the equation. It has 6 valence electrons. And so you have 6, and 1 times 6 is 6. And you add these, and you get 8 valence electrons. You have 8 electrons available.
The third step, you find the number of electrons involved in bonding.
For this, you will take the electrons needed minus the electrons available, and you'll get 4 electrons involved in bonding.
The last step, you find the number of bonds.
To do this, you take your electrons involved in bonding and divide them by 2, and you'll get 2 bonds needed for, you have 2 bonds for your equation.
So after you find the number of bonds in the equation, you want to make the correct Lewis structure. And then, what molecular shape would it be?
This is linear. It has 2 shared pairs and 2 unshared and 0 unshared pairs. This is triangular planar. It has 3 shared pairs and 0 unshared pairs. This is tetrahedral. It has 4 shared pairs and 0 unshared pairs. This is bent. It has 2 shared pairs and 2 unshared pairs. This is triangular pyramidal. It has 3 shared pairs and 1 unshared pair. And last but not least, remember to draw all of your bonds in true to shape.